This is a meteorite, Stephen. Have you ever seen a meteor in the atmosphere? That's a rock like that, a mineral coursing through our atmosphere at tens of thousands of miles per hour.
How do you know?
How do we know? We measure their velocity. We can track them on
Well, how
radar.
do you know that this is a meteorite?
Oh, this has all the characteristics of a meteorite. Its composition, its density, its structure. It has that weird pattern on it. But if you're really curious, what we could do,
So where has this come from then?
this one was found in Argentina, in a place called the Field of the Stars.
And this could have come from anywhere in the universe.
Exactly. This is basically a fragment of an asteroid that existed before the Earth, Stephen. This is a fragment, a fossil relic of our solar system from over 4 billion years ago, older than our Earth, because our Earth formed at its core, our Earth has iron inside of it. It has an iron core, just like that. That's pretty heavy, right? That's not, and it also made this here. This, if you give this to your sweetheart, if you compress this by 100,000 times and give it to your sweetheart, she'll be really happy about that. That's pure carbon.
So that'll turn into a diamond.
That'll turn into a diamond. I like to say, pressure is what turns dust into diamonds.
For anyone that can't see this right now, it looks like a dice. It's almost identical to like a black dice.
It's
but light as
exactly.
well.
Yep, it's very light. Now contrast that to, and here's a piece of rock. This is mostly volcanic rock. I collected that in Antarctica. I've been to Antarctica twice. To the South Pole. I collected that specimen there. It has holes in it. See the holes?
Yeah.
Those come from bubbling, escaping volcanic gases. So there's volcanoes down at the South, in Antarctica, not the South Pole. And then here's this one. This is found in Namibia.
Heavy.
So this is a meteorite found in Namibia, also from the same process that formed our solar system. This was found by the natives that lived there several hundred or maybe even 1,000 years ago. This one's particularly nice. If you're not watching, it looks like a human foot.
And I can't explain how unbelievably heavy that is.
Yes.
I don't think I've held something that's this size but this heavy before.
It's extremely dense. It's the dense. So what happens when a star tries to make the iron in that? It takes more energy to make that, fuse that nuclei of iron than is given off in the fusion process. So therefore the star can't support its weight. It collapses, it explodes and rebounds. Now, when your listeners or viewers go to my website and if they win one, you'll see how attractive these things are to magnets. It's a very powerful, it's called a rare earth magnet, neodymium magnet.
Jesus.
And you see, so attach it to the meteorite. It's fine to do that. You can do that.
Wow.
That sound, I love that sound. That ping. So this material is highly magnetic. And iron, which is primarily the constitution of this meteorite, has the exact same chemical structure as in your blood, there's a molecule called hemoglobin.
Mm-hmm.
It's almost identical to the chlorophyll molecule that plants have, except chlorophyll has a magnesium atom at the center of its chemical matrix. But in hemoglobin that's going through your veins right now is iron. That iron came from that supernova. Eventually your mother, and the food that you eat has some iron in it, and then your body starts to produce blood. And that blood has the same chemical composition as the stars.